Continuing on with our investigation into sequential logic, we're going to move on to a state graph. Now, a state graph can be viewed in a number of different terms that are all interchangeable. You might see the word state graph. You might see it as FSM. That stands for a finite state machine. You might also just see it referred to as a state machine. There's a lot of different names that this can be, accomplish the same idea. What a state graph really is going to be boiled down to is a list of steps for our logic to follow. Well, let's keep working on our little example about the touch light switch. Well, for our touch light switch, the steps are fairly straightforward. The items are, the light is off. If you get a touch, turn on the light. Then you go to the light is on. If you get a touch, light is off. You get a touch, light is on, so on. We see these items being relayed. Okay, let's talk about a state graph. And a state graph is going to be, how do we take these steps and represent in a visual form? I want to see these steps visually. Okay, what we're going to talk about is there's two different ways to do a state machine, and we're just going to focus on one to get the basic idea across. And we're going to look at what is a more finite state machine. And a for finite state machine is going to be the following. We're going to have a circle. This circle is going to have some type of name in it. That name is a step in our process. Along with the name and the step, we're going to have what we want our output to be. And then we're going to have transitions. We'll call these with the arrows. These arrows are the transition to a new state or a step. So that's, will also this be name, step. All of this is a state. And how do we make the transitions? Well, the transitions will be based off of some input. And it might be if the input is a 1, we move one direction. If an input is a 0, we move to another direction. The more piece really refers to where the location of the output is. So a more, we're going to say the output is inside that state. All right, so let's do our light example. All right, let's just scroll up real fast and look at what we see happen. We go light is off, light is on, off, on. If we kept writing out, it would be off, on, off, on. Let's just break it down into, really, we can just focus on two of these states. And those two states are what's triggering all the time. All right, so in our light example, let's draw out our two states. We have one called, let's say this is the lamp off state. And then we'll have another one called our lamp on state. Okay, first thing we want to do is set up how our light is going to work. In the off state, we're going to say our light is off. For us, that's the value of 0. The other state is going to be our light is on. On for us is going to be the value of 1. Okay, so how do I move between these two states? Okay, how do I move is if we touch that light switch, from going off, we turn on. And if we're on and we touch the light switch, we're going to go off direction. Okay, so what happens if we don't touch the light switch? Well, if we don't touch the light switch and we're off, we want to stay off. So we'll have it loop onto itself. The same thing with the light switch being on. If we do not touch, then I want it to be an off. All right, so this is our state graph. The state graph is always going to be the circles and the arrows that are connecting everything together. Okay, from the state graph, we might want to represent this in another format. Well, that's going to refer to as our state table. And the state table is going to be that we show the state graph in a text form. Okay, so how we're going to end up showing this out is a state table is usually always broken up into 3 different sections. It's going to follow somewhat of a truth table type of format. One section is going to be what is we're going to call the current state. The middle section we refer to as our next state of where it is we're moving to. And then our last piece will be our output. All right, so let's draw this. So if we look at this, current state, that's the circle that you're in. The next state is where is that arrow going to? And then the output is the section at the bottom of your state. All right, so let's go back up here. To make things a little bit easier, input of touch, we're just gonna say that's T. So we're gonna say that's T1, T is equal to 0. So we're just gonna shorten it. The light, we're gonna just do as a capital L. So this is L0, L1. All right, and then let's do our state as, let's call, just to make it a little bit easier for us, let's call this state A and state B. Okay, so then let's draw out our state table. Our state table, the output is just L. Our current state is going to be, we're either in state A or we're in state B. What is our next state going to be? Our next state depends on what is the value of T. Is T a 0 or is T going to be a 1? All right, so let's go back up here and let's take and dissect everything. Okay, so we're starting off in state A. And the first thing we want to see is what is our output? Our output is L is a 0. Okay, so let's go down to our state table and let's plug in what our output L is going to be. Our L is going to be 0. All right, now we're going to look at what T values are. All right, so T of a 0, we see that we loop back onto itself. So we're going to come down here and say, okay, when T is 0, where are we moving to? We're moving to A. Let's scroll back up. We scroll back up, we have T equal to 1, and we see if we move this direction here, that's moving us into our next state, which is B. So we'll go down here and we'll say, okay, when T is equal to 1, we go to B. All right, so then let's fill in B. So here is state B. So here's B. Look at our output. Our output is a 1. So we'll put L as a 1. And let's look at our 0T will be, we loop back onto ourselves. So we go back to B. When our T is a 1, we see we're moving into A. All right, so then that sets up what would be our state table. Now you can easily go from state table, take this and you could draw it out to represent your state graph. How will we draw this out? Okay, well, we look at this and we say, okay, I have an A and I have a B. When it's A, my L is equal to 0. When I have a B, my L is equal to 1. Then we follow this and we look at T0. I write out T is 0. I go back to A. And then I say if t is equal to 1, I'm going into B. On B, if I get t equal to 0, I loop back onto itself. And if I get t is equal to 1, you see that I move into A. So we should be able to move between a state graph and a state table very fluidly. It should be able to be interchangeable. You could take one and produce the next value. Now, the last thing we need to do is I need to figure out what is the circuit I'm creating. So we need to implement our design. And implementing the design is figuring out how do I produce the circuit. Okay, so to produce the circuit, remember, let's look at our items. We are producing an output. We have an input. We have a combinational piece. And then we're going to have a memory piece. And we got to get all of these items to work together. Okay, how we're going to do this? Well, this memory piece, the memory, this is our state. Everything else we produce ends up being this combinational piece, which for us, this combinational piece, we could think of it as the K-map we're trying to solve. What is our input? Our input is T. What's our output? Our output is L. Okay, so how we're going to produce this is we have a table already. That table is set up as current state. I have an A and I have a B. I have a next state. Next state is based off of a T of 0 and a T of 1. And then I have my output, and my output is L. All right, so let's fill in L's for each of these. Let's put in the next states for each of these. And what I want to do is figure out this memory unit. So the memory unit has to have some name to it. For us, let's say this memory unit is, let's say it's S. Okay, so current state is going to be S, and my next state is X star. Remember, the star is always for the next value. Okay, so I have to look at how many different states I have. Here I have 2 states. I got to give each state a value. So in this state, I'm going to say S0 means I have it in state A, and a 1 means I'm in state B. So then I'm going to go into the next state spot. I'm going to put all A's to 0. I'm going to put all B's to 1. Okay, so I might even redraw this. So let's redraw it as S. I have a 0 and a 1, and I have what the next values are going to be. Those are my S stars for T is 0 and T is a 1, and then I have my L's. Okay, what I'm going to do here is I'm going to take this, and it's from this item here that I need to create my K-maps. So the K-maps are going to be, what do I need to produce? I need to produce L, and I need to figure out what is my S star. So there's going to be 2 K-maps I would produce. Okay, so in this setup here, for S star, how do I produce S star? S star is going to be a 2 variable K-map, where the 2 values are going to be my S and the T. Okay, so I'm going to fill in these spots. Okay, so let's look at this purple spot here. That purple spot is S is 0 and T is 0. S is 0, T 0. That gives me that value should be a 0. Okay, I'm going to erase all the purple. All right, so let's say the next one is this item in green. That's S is a 0, and my T is 1. Okay, so that says that value should be a 1. All right, I'm going to erase all the green piece now. All right, let's do the next piece. Purple again. Well, that's S is 1, T 0. Well, that value should be a 1. And let me erase the purple. So now we're in orange. Here's this orange piece. That's an S1, that's a T1. My value needs to be a 0. So I'll write in 0. All right, so now I can solve this. How I'm going to solve is I'll say S star is a D flip-flop. So we can leave everything the way it's drawn. I'm going to solve it. So here, what I'm really saying is my memory unit. Remember, our memory, we're saying this is a D flip-flop, which is my D input. So that's my, let's call it here, in this case, let's call this S sub D to say that's the S memory unit that we're producing. This is what I am solving for. That is what the K-map produces. The K-map is going to produce this. So I get that SD is, I have two terms. These two ones are not next to each other. So that is T bar S or T S bar. All right, so those are those two terms right there. And then L, for us, this L, it's only one variable. That one variable is L is equal to S. So here we see if S is 0, L is 0. If S is 1, L is 1. Okay, so how do we produce this? Is we see, okay, what's coming in on the sequential logic. Okay, I have my L. I have my memory. Okay, here's my D flip-flop. I'm going to draw it the other way around. So here's SD. I have my clock, which is enter into the system. My output is S, and S is equal to L. Okay, so how am I going to produce SD? SD is, I have two AND gates. They get ORed together to produce SD. What are the inputs into that AND gate? Well, the input is T. So I'll need to produce a T bar. So I'll say, okay, T bar is coming in on one of them. T is going in on the other one. Then they're going to be based off of S. So let me do S in purple here. So S comes in directly, and then I'll have a NOT gate for the other one. And we can see that's how it is that we're going to create this sequential logic circuit for this light switch example. So just as a summary, let me write out a summary right here. Our summary is, if we're going to look at how to solve a circuit, first thing is we create a state graph. Second step is we would do a state table. Third thing is we'll determine the number of flip-flops needed. And this is going to be based on the number of states. 4 is we'll plug in bit combinations for the states. And then 5 will draw K-maps from the state table. All right, so those will be the steps that we'll follow through to create this. All right, next time we'll do a full example from starting a new problem and creating all 5 of these steps.